This lesson is going to be dedicated to exploring the properties of exponential functions, um, specifically their graphs and the transformations of those graphs in such a way that you shouldn't need to graph it with a graphing calculator or some sort of graphing program. Just get a basic idea of what the graph looks like, a couple of basic properties, and sort of its general shape. Okay. The first function we're gonna look at, well, actually, I should define what a transcendental function is, because sometimes you hear that the exponential and logarithmic functions are also called the transcendental functions, along with trigonometry functions, sine, cosine, tangent. These are all transcendental functions, which it just means that they transcend the normal realm of algebra. That is, you cannot rewrite any of those functions in a way that it's some sort of complicated polynomial. They have to be written in sort of with using the new notation, and it can't be written in some sort of other way, some sort of basic algebraic way. So that's what a transcendental function is. But at any rate, let's move on into our first function, which is f of x equals 2 to the x, and it has this basic shape. There's a couple of things that you need to take note of. One of them is that it's asymptotic to the x axis, which is also denoted as y equals 0. So HA means horizontal asymptote is at y equals 0. And the other thing is to notice that it has an intercept. It has one intercept here on the y-axis. So here at 0, 1 is a y-intercept. And so it has this upward curving shape. For the calculus students, you will see that this is a continually increasing function. This is an increasing function on its entire domain. Okay, so what happens if we add this, instead of an x, we have a negative x? Well, the graph is going to flip over the y-axis, and that should make sense to you. All right, instead of just memorizing that, let's see if we can rationalize. So whatever x was, now we're going to have the opposite. So if x was 3, now we're going to have negative 3. If x was 5, we're going to have negative 5. If x was negative 1, now we're going to have positive 1. So whatever the original value was, it's going to be the opposite now. So our graph is going to flip over the y-axis because it's changing from positive, say, 3 to negative 3. Okay, so now we have this curve. What does it do to the asymptote and the y-intercept? Actually nothing. Since it flips over the y-axis, it flips this point stays stationary, so the y-intercept stays the same, and it's still asymptotic to the x-axis. What happens if we add a 1 up in the exponent? Well, what's going to do is it's actually moving the entire graph. The graph stays exactly the same shape. It just slides directly to the left 1. All right. Again, why is that? Well, normally when you put 1 in for x, all right, you get 2 out for y. Now when you put 1 in for x, it's going to be the same value as if you had put 2 in for x. All right. So effectively, if we wanted the same y value, we need to go to the x value that's 1 less. So the x value of 1 less is essentially moving to the left 1. That's the way I think about it. It may not work for you, so maybe pause this video right now, see if you can't rationalize it in a way that makes sense to you so that you don't have to memorize this rule. At any rate, well, how does this affect the two basic characteristics of our graph, the asymptote and the y-intercept? Well, since we're sliding directly to the left 2, the horizontal asymptote doesn't change. It's still y equals 0. What does change is our y-intercept. All right, our y-intercept used to be at 0, 1. Now it's 0, 2, and it's only because whatever the original value is when we put 1 in, it just happened to be 2. Now that's going to slide over and become our y-intercept. Okay, what happens if we add a plus 1 to our original function? It slides the whole graph up 1, all right, and I think that makes sense. So whatever y value we got when we pick an x. So if x was 5, so whatever our y value, whatever 2 to the 5 is, now what we're going to do is we're going to add 1 to that value. So no matter what we put in for x, the original y value, we're just going to always add 1 to it. So it's going to slide everything up 1. So it slides our horizontal asymptote up 1, and it slides our y-intercept up 1. All right, so that shouldn't be a surprise. What if we put a negative sign out in front of our graph? What's going to happen? Well, we can see here that it flips it over the x-axis. Why does that make sense? So no matter what value we put in for x, normally we got some sort of y value, but now it's going to be the opposite of that y value. So if that y value was 2, now it's going to be -2, etc. So that's the reason why it flips over the y-axis. Again, see if you can't rationalize your way through it so you don't have to memorize the rule. Take a look at what's happening to the numbers. So now what's happening to our two critical values? The horizontal, since it's flipping over the x-axis, our x-axis remains the horizontal asymptote. What happens to our y-intercept? It used to be up here, now it's down here. It flipped over the x-axis, so now it's 0, -1. Now, we chose to explore graphs with a base of 2. We could have easily have done a base of e, the natural number e, which, remember, e is just a number, right? It's a very long number, but it's still a number. And so if we have that number to the x power, it's still going to give us this general shape. It's going to look almost exactly like the 2 to the x. It's still asymptotic to the x-axis. It still crosses the y-axis at 1, and it's still an increasing function. The only difference is going to be that these basic shapes, they're going to maybe be a little bit flatter and then come up steeper. Like, so this line right here is 5 to the x. It's going to be steeper here and then flatter here. All right, and here's e to the x and then e to the 2x. All right, so this unusual line here, we would have expected this to be like to the -x perhaps, but instead it's when I chose sort of a fraction, a number between 0 and 1 as the base, and it flips it over the y-axis. Why is that? Well, if we were to expand this, it's the same thing as 1 over 2 to the x, right? 1 to the x power is just 1, and then 2 to the x power in the denominator, and well, 2 to the x power, I can move that up to the numerator and make that 2 to the -x power. So as it turns out, 1/2 to the x power is the same thing as 2 to the -x power. And we had talked earlier how 2 to the -x power is just a reflection over the y-axis. So we shouldn't be surprised to see sort of this effect. So that's an exploration of the graphs of exponential functions.